Okay, so pretty much sections talk about slope. And you're probably going to get my rant of the day. This is one of those topics that professors at four-year universities, mathematical professors, get all bent out of shape about, because they say that they're getting STEM students in calculus who do not understand slope, and the fact that slope can be described as a rate of change, which it can. And they get really, really tense about the fact that we're sending students out of college algebra without being able to understand slope. So here's my rant of the day. And I know you guys aren't doing this, but I'm a subscriber to the UConn Happenings Facebook group. So I'm in that group. And the last couple of days, for some strange, bizarre reason, people have been posting math problems. And someone
I saw the one last night.
Oh, did you? So somebody posted this. So what root do you take of 8 so that when you multiply it by the square root of 4, you get 4? Well, that's 2. What do you multiply times 2 to get 4? Well, that would be 4. That would be 2. So what root would you take? Well, you'd take the cube root. So what's the question mark? The question mark's 3. You take the cube root of 8, you get 2. 2 times 2 is 4. And the answer that the vast majority of people posted was use an app. Take your phone out and use this app and take a picture of it, and it will give you the answer. So the vast majority of people told the woman to cheat. That's what you're doing. When you take your phone out and you take a picture of it and get the answer, you're cheating. That's what you're doing. And the reality of the situation is, if you cheat by doing that, you don't understand the concept. And when you get to calculus, you're lost. You could say, well, I'm not going on beyond college algebra, so I don't care. Well, maybe so. But then you got to take a test. And you can't take your phone out and take a picture of it with your phone on a test, or you're going to get flagged for that. And you're going to get a 0 on your test. So it could be a problem even closer down the road than getting to calculus. But the fact of the matter is, every time you take your phone out or you use an app to do something like this, you're cheating. That's the reality of the situation. It's important that you understand what you're doing and not just how to get the answer. Honestly, understanding that's why those of you who actually turned in your papers for the first exam, you could see how much your score went up. Because if I see on the paper that you turn in that you understand what you're doing, but somehow, and I even have people that get it right on their piece of paper, completely and totally right, circle the correct answer, and then somehow either second guess themselves or they have a transcribing issue getting it from their paper to MyMathLab, and the MyMathLab answer is incorrect when the answer on their paper is correct. I give you full credit for that. So what's important to me is that you demonstrate understanding of the process, how to solve the problem. Not that you get the right answer, although the right answer is important because you want your plane to fly and you want the car to run and all those kind of things. So getting the right answer is important, yes. But understanding how you get to that correct answer is more important. To me, it is. Anyway. So when you talk about slope, it's important that you understand what it means, because you got to use it later. It doesn't, unfortunately, go away. So erase this. So you heard my rant. Don't cheat. I mean, when I was in college, when I was in engineering school, I had friends of mine that said, oh, you can always look at somebody else's paper and see what they're doing. And I said, but that's cheating. Well, yeah, but who cares? Well, I care. And number one, I don't know that the guy next to me knew what he was doing any better than I knew what I was doing. So I never trusted looking at somebody else's paper, because I figured I was just as smart as they were. I probably knew as much as they did about it. So I never, ever cheated that way. But anyway, so slope. What's slope? So back in chapter 1. Oh, well, that's interesting. PowerPoint's helping me and I don't need it. Don't help me, PowerPoint. So back in chapter 1, we introduced the concept of the coordinate plane, where you have two axes, and that's so completely and totally vertical, as you can tell. We have two axes that are perpendicular to each other, and we give the name. We call the horizontal axis X and the vertical axis Y. And we can plot points, ordered pairs, on this coordinate plane. So we have ordered pairs. Well, let's say 2, 3. 1, 2, 1, 2, 3. So here's an ordered pair, 2, 3. And maybe, I don't know, -1, -4. So when you have two ordered pairs, 2 points on the coordinate plane, you can connect those points you can connect the dots. So you can draw a line between them. Let's see if I can draw a line between them. So when you draw the line between them, you're drawing a description of all the ordered pairs that satisfy the equation of this line, whatever the equation is. And we can find the equation of this line, as a matter of fact. We can do that. So the slope describes how steep the line is. And this one looks pretty steep. So I would suspect that the slope is bigger than 1. So that's all of the slope describes. But the slope also describes the rate of change from one point to the other in terms of y with respect to x. So it tells me how much the thing rises compared to how much it moves in the x direction. So it tells me the rise over the run. So it tells me how steep this line is. And you're given a formula for it. And we use subscripts. And the subscripts just tell us, so a subscript, let's talk about the difference between a subscript and a superscript. A subscript is down and to the right. And a subscript simply tells you that this is different than the other thing with the other subscript. So subscripts just denote a difference in two values. A superscript is to the right and up. So a superscript denotes a power, an exponent. So if we have subscripts y sub 2 and y sub 1, that just simply tells us that they're two different values for y. And we have x sub 2 and x sub 1. That just tells us we have two different values for x. So the formula says just take the difference in the y values and divide it by the difference in the x values. So I have 2 points two different y values, two different x values, and I just take the difference in the y's over the x's. And it actually doesn't matter which point, you put for y2 and which one you put for y1. You just pick one and do that. So if we pick the second point, so -4 minus 3 would be the difference in the y's. So we're taking -4 and we're subtracting 3, the difference in the y's, over the difference in the x's, -1 minus 2. Then we get the slope, which would be what? -7 over -3, or 7/3. And I said I suspected that the slope was bigger than 1 just by looking at the line that I drew. It looks kind of steep, and 7/3 is what? 2 and 2 1/3. So it's over 2. So I could just tell by looking at it that it was fairly steeply inclined. So the slope of this thing is going to be bigger than 1. Now, we're going to review this at 12:30, but since it's increasing or it's going up, we have an up incline here, the slope will be positive. And if it goes down, the slope would be negative. So I know by just looking at this that the slope is, bigger than 1, pretty steep, and that it's got to be positive because we're going up. To get from -1 to get from -1, -4 up to 2, 3, I got to go up. As a matter of fact, I have to go up 7 and to the right 3, right? I got to go up 7, 1, 2, 3, 4, 5, 6, 7. Got to go up 7. And I have to go over 3. So I'm at -1. So I got to go 1 right there, 2, 3. I've got to go to the right 3. So I'm going to go up 7 to the right 3. So the slope tells me how to get from one point to the other. And since it's 7 over 3, I've got to go up 7 units and to the right 3 units to get from -1, -4 to 2, 3. Got to go up 7 units and to the right 3 units. So the slope defines the change in y with respect to the change in x. That's what it tells me, that it's going to move up 7 units and to the right 3 units. So 7 over 3, we're going to go up 7 with respect to the right 3. Okay. Now I can also, I need to write down what points I've made up here. I can find the equation that describes this line, and it's not going to be pretty. That's what you get when you just make stuff up out of your head. So if I know the slope is 7/3, and I know the 2 points, 2, 3, and -1, -4, then I can find the equation of the line that describes that line that was on the coordinate plane when I connected these 2 points with a straight line. And the easiest way to do this is the point slope equation. Now, if you have something being described by point slope, then what do you suspect you need to know to be able to find the equation of the line? You need to know a point, and you need to know the slope. Those 2 things you can plug in and then do the algebra, the arithmetic, and find the equation of the line. So it looks like this. Where, again, the subscripts denote that that's a point. So y1, x1 is one of your points. And it doesn't matter which one you use. You can use either one you want. Any point that's on the equation of this line, you can plug in there. And then you plug in the slope. Okay, so use 2, 3. That's point and slope form. And that's all you have to do. That's it. You're done. Why is that point and slope form? Because you can just look at this, and that number that's outside your parentheses on your right-hand side, that's your slope. And then you look at the two numbers that you're subtracting from x and y, the numbers you're subtracting from x and y, and that's your point. So the point is 2, 3. The slope is 7/3. Now, you could have used the other point. This is perfectly valid. That's actually the same equation. Now, it doesn't look like it's the same equation, but it is. It's exactly the same equation. And you can prove that it's the same equation by putting it in slope-intercept form. Now, we would rewrite this because minus a minus is awkward. Those are exactly the same equation. Does not look the same, but they are. And as I said, the way you could show that those are exactly the same equation is by putting this in slope-intercept form. Okay, so what's slope-intercept form? Well, slope-intercept form is the form that you just look at the equation of the line and you know what the slope is and you know what the y-intercept is. So slope-intercept tells you slope and it tells you the y-intercept. And if you have the slope and the y-intercept, you can plot the y-intercept and use the slope to find a second point. So you can actually graph it just by using the slope and the y-intercept. Okay, let me write these two things down. What did I do with my pen? So my granddaughter, who's not 3 years old yet, she'll be 3 in April, but she's denoted colors belong to a certain person. So she handed me this pen, which is purple. And I don't remember where she found it, but it's my husband's pen because it's a Banner Co-op pen. And she said, no, that's not Pa's pen. That's Nana's pen because it's purple and Nana is purple. Anyway, so my purple pen. Let me write these two things down. Out. Okay, so what's slope-intercept form? Well, if you take the equation and you solve it for y, that's slope-intercept. So if you get y on the left-hand side and everything else on the right-hand side, that's slope-intercept form. And just by looking at the equation, you know that whatever you're multiplying times x is the slope. And whatever you're adding to the mx, whatever that number is out there, that's the y-intercept. So just by looking at the equation, you can determine the slope of your equation and the y-intercept. So let me write these two down. Well, let's do one at a time. So let's put this in slope-intercept form. So what I need to do is first distribute that 7/3 across. I said it wasn't going to be pretty, but we're going to do it anyway. So I'm going to get 7/3 x and 7/3 times -2. To multiply fractions, you multiply the numerators and you multiply the denominators. So this would be 7 times 2, 14, over 3 times 1, 3. Okay, and now we're going to add 3 to both sides. So I'm going to add minus 14 thirds and 3. So I need to write that in terms of a fraction with a denominator of 3. So 3 is 9 over 3. Is that negative 5 over 3? So the y-intercept is 1 2/3. Okay, let's go back and look at my graph. I got a sign error somewhere. Oh, negative 5/3. So negative 1 1/3. That's pretty close to what I graphed. I mean, that's pretty close. Not bad. Considering how poor my graph is, it's not too bad. So it crosses the y-axis at negative 5/3. Negative 1 2/3. I think that's what that is. Okay, so let's show that it doesn't matter which point slope form I take. When I solve for y, I should get the same equation. So what was the other one? Y plus 4. Cross your fingers that I get the same answer. Distribute the 7/3 across. Subtract 4 from both sides. Multiply by 3 over 3 to get a common denominator. Is that minus 12 thirds? Is not 4 is equal to 12 thirds? Same thing. So we get what? Y equals 7/3 x minus 5/3. Woohoo! So we have point slope form, which is this form here. And that's all MyMathLab requires you to do. It wants you to leave it written in that form. And then you can solve that for y and get slope-intercept form. So the slope of this line is 7/3 and its y-intercept is negative 5/3. Okay, and so the last form of a line is called general form. And it is by far the least helpful of the 3 forms of the equation of a line. But we use general form generally. So if we look at other functions, equations of functions, we frequently write them in general form. And general form means that you get everything on the left-hand side and 0 on the right. So what you want to do, for example, in this function, is get the 7/3 x over on the left and the negative 5/3 on the left. And that's sort of general form. You probably want to clear the fractions to get it in general form. So what you do is I'm going to move the 7/3 x to the left-hand side by subtracting it. So it's going to become negative 7/3 x. And I'm going to move the negative 5/3 to the left by adding it to both sides. So it's going to become positive. And that is general form, except we're not real keen on fractions. So I would multiply both sides of this equation by 3. Remember, you can clear fractions by multiplying both sides of your equation by the common denominator. In this case, the common denominator would be 3. So I'd multiply everything by 3. And when I do that, if I multiply negative 7/3 by 3, I get negative 7x. So the 3's go away. I multiply 3 times y, I get 3y. I multiply 5/3 times 3, I get 5. So that's general form. And it's, as I said, in my opinion, the least beneficial. It's not even really, it's the form that we start with when we graph things using intercepts. So when we graph equations using the x and the y intercepts, we start with an equation that's in general form. So we have point slope form, slope intercept form, and general form. In general form, again, you have everything on the left-hand side of the equation, so x and y and your constant, and you have 0 on the right. And this is a beneficial form to put stuff in later. Right now, it's not particularly helpful. But when it asks you to put it in general form, that's what you do. I don't think I got enough slides here. Okay, we're just going to ignore this for a second. We'll do this in a second. Let's talk about parallel and perpendicular real quick. All right, so if you have two lines in the coordinate plane that are parallel to each other, they have the same slope. If you have two lines in the coordinate plane that are perpendicular to each other, then their slopes product is -1, or the slopes are negative reciprocals. So if I tell you to find the equation of a line that goes through the point that's parallel to a given line, it's got the same slope as the line that you're given. If it tells you that it's perpendicular to a line that you're given, then you have to find the slope of a line that's perpendicular. For example, so if they say find the equation of a line perpendicular to this one, then how do you find the equation of a line perpendicular? To find the slope of a line perpendicular to this one, you take this slope here and you flip it over. You find the reciprocal. Then you take that value and you change its sign. So two lines that are perpendicular to each other, when you take their slopes and multiply them together, you get -1. So whatever they give me, whatever point they give me, a line perpendicular, its slope, that's how we denote that. So perpendicular, its slope would be -2/3. You take the slope of the line that you're given, you find the reciprocal of it, and then you change the sign. Parallel lines have the same slope, or if two lines have the same slope, they're parallel. Two lines that are perpendicular have negative reciprocal slopes. So if you take the two slopes and you multiply them together, you get -1. So how do you find the slope of a line that's perpendicular to a given line? You take the slope of the line that you're given, you find the reciprocal by flipping it over, and you change its sign. All right, I did want to, and I have 10 minutes, so I have time to do this. I did want to look at a complex fraction. All right, so what I have here on the slide is called a complex fraction. Why is it a complex fraction? Because the numerator contains a fraction and the denominator contains a fraction. So I have a fraction because I have this bar right here. So that makes this a fraction. And the numerator is the stuff that I'm highlighting in pink. So that is the numerator of this fraction, and it contains a fraction. And the denominator is the stuff that I'm highlighting in green. And the denominator contains a fraction, 1 over x. The numerator contains a fraction, 1 over x. So if the numerator and or the denominator of your fraction contains a fraction, it's a complex fraction. That's what this is. Now, how do you simplify a complex fraction? Well, by using the definition of what a fraction is. So if I have a fraction, a over b, that is by definition a divided by b. That's what it is. That's the definition of a fraction. So if you have 3 halves, that is 3 divided by 2, which is 1.5 in decimals, or 1 1/2 in fractions. But that's what it is by definition. So we can rewrite this in terms of a division. And then we're going to combine the stuff in parentheses with a common denominator. So 1 plus 1 over x, we can find a common denominator, which would be x. So we're going to multiply 1 by our well-chosen 1, x over x. And we'll do the same thing in the second fraction. We'll multiply the 3 by x over x. And we're going to get a common denominator in these two terms. So we get x plus 1 over x. So we have now x over x plus 1 over x. So we have x plus 1 over x divided by, what's that going to be? 3x minus 1 over x. Now, the definition of division, again, 3 halves is 3 divided by 2. But in terms of a multiplication, this is 3 times the reciprocal of 2. So 3 divided by 2 is 3 times the reciprocal of 2. So it's 3 times 1/2. Well, yeah. 3 halves is 3 divided by 2, which is 3 times 1/2, which is 3 halves. Yes, that is true. So to find this division, we take the reciprocal of the divisor and we multiply. This thing's called the divisor. So the thing that you're dividing into the other thing is the divisor. This thing over here, FYI, is called the dividend. So when you take a dividend and you divide it by a divisor, you get a quotient. When you divide things, you get a quotient. And yes, you do need to, did I spell that right? Dividend, yes it is. You do need to memorize those names because we're going to use them in chapter 3. So the dividend is the thing that's being divided. The divisor is the thing you're dividing into, the dividend. So in our 3 halves, 3 is the dividend, 2 is the divisor. 1.5 is the quotient, okay? So we take the reciprocal of the divisor and multiply it by the dividend. So we just flip it over. Flip the divisor over and multiply. Now what happens? Well, the x's will cancel. And you get x plus 1 over 3x minus 1. Now, you still have a fraction. That's fine. You still have a fraction. That's okay. But you don't have a fraction in the numerator, and you don't have a fraction in the denominator of your fraction. Your numerator is x plus 1. Your denominator is 3x minus 1. So now you have a simple fraction. You don't have a complex fraction. So complex fraction is where you have a fraction in the numerator and or the denominator of a fraction. And to simplify that, you're going to actually rewrite this as a division, find a common denominator in the numerator and or the denominator, and then use the definition of division. Definition of division, you take the dividend and you multiply it by the reciprocal of the divisor. And that simplifies your fraction. You may not think it's any simpler, but it is. It's a way simpler than the thing that I've got highlighted in purple, yellow, and green up there. I think that might be where we quit, because I have another example that's probably more complicated than I want to get into today. Are there any questions? Well, we are going to talk about this some more in the 12:30 period. We're going to actually do a little bit more review. And we are actually going to look a little bit at section 2.5. Oh my goodness gracious, do you make that section 2 difficult? Holy cow, do you make that thing difficult? When it's actually probably the simplest section in this chapter. And boy, howdy, do you complicate that. It's just a simple matter of moving things around in the coordinate plane. So we'll talk about that, and it can be summarized literally in a table. The entire section summarized in one little table. All right, well, if there aren't any questions, then I will see you again at 12:30.